Hey everyone, and welcome to This Explainer. Today, we're zeroing in on something absolutely crucial for modern manufacturing procurement: how to make incredibly smart decisions when sourcing waterjet cutting for 2026. If you're a sourcing professional or a supply chain engineer, you know that picking a cutting technology isn't just about pointing at a catalog and grabbing the flashiest machine. It's actually all about looking at things directly from a procurement manager's perspective. Specifically, how to choose the right cutting process based on your material's exact hardness and how to master that delicate trade-off between cost and efficiency. So grab your notepads because we're going to break down exactly how to optimize your cost per part. I want to kick things off with this quote from the 2026 Sourcing Guide. A common mistake in sourcing is overspecifying. Seriously, this is a massive trap. Throwing heavy-duty abrasive cutting at a project that really only needs pure waterjet, it doesn't just waste money, it unnecessarily drains your budget, stretches out your lead times, and totally inflates your consumable costs. It's literally like using a sledgehammer to drive a thumbtack. All right, let's look at our roadmap. We'll be covering 1. Hidden waste in procurement. 2. How material hardness dictates process. 3. The pure versus abrasive showdown. 4. That crucial cost versus efficiency trade-off. And 5. Optimizing supplier evaluation. Jumping right into Section 1, Hidden Waste in Procurement. Let's look at why treating all cutting technologies exactly the same is a huge hidden drain on your supply chain budget. Fundamentally, we have to understand the technical split here. Pure waterjet uses a supersonic stream of highly pressurized water. We're talking up to 90,000 psi, channeled through a tiny jewel orifice. Think of it as a super high-speed water saw. It's fast, incredibly precise, and absolutely perfect for soft, porous materials. On the flip side, abrasive waterjet uses that exact same pressurized water stream but acts like a vacuum to pull in crushed garnet. The water accelerates those garnet particles, transforming the tool into this heavy-duty, high-powered grinding stream that can easily slice right through inches of solid titanium. Moving to Section 2, Material hardness dictates process. As a procurement manager, this is really where your decision-making starts, matching material density to the right tool so you avoid overspecifying. You can think of this as your sourcing cheat sheet. For soft goods, things like rubber gaskets, foam packaging, or thin plastics, pure waterjet is the absolute champion. The stream is incredibly thin, with a kerf width at just 4 to 10 thousandths of an inch, meaning it creates almost zero material waste and leaves fantastic edge quality. But when your material density goes up, pure waterjet kind of loses its teeth. That's exactly where abrasive waterjet steps in for dense metals, stone, and composites. Sure, you get a slightly wider kerf and a moderate environmental impact because of the garnet disposal, but you gain the power to cut virtually any known hard material. Now, for those of you working in high-value aerospace or medical sourcing, here is an absolutely crucial point: avoiding the heat-affected zone, or HAZ. Unlike lasers or plasma, waterjet is a cold cutting process. Lasers rely on thermal energy, right? And that heat can actually alter the molecular structure of the metal right at the cut edge, making it brittle. Waterjet entirely preserves the original material properties, like the T6 temper in aluminum. So if your project needs secondary welding or precision tapping down the line, you aren't fighting hardened edges, and you're completely avoiding those costly rejection rates. Section 3, the pure versus abrasive showdown. Let's compare these two head-to-head on speed, cost, and agility. We have to answer a super common buyer question here. Wait, isn't waterjet more expensive than laser cutting? Well, for thin carbon steel, honestly, yeah, laser cutting is usually going to be cheaper and faster. But as soon as material thickness increases, or when you're dealing with reflective metals like copper and brass, lasers really struggle. That is exactly when abrasive waterjet takes the clear lead. It becomes highly cost-effective and technically vastly superior. And that brings us to the magic number, 1. As a buyer, flexibility is everything, right? Well, waterjet cutting is so agile that a minimum order quantity, an MOQ, of exactly one single prototype is perfectly viable. Why? Because unlike stamping or molding, there's absolutely zero expensive tooling to create upfront. You can literally order a unit of one for a proof of concept today, and then seamlessly scale up to thousands tomorrow once the setup time is amortized, which drops your cost per part significantly. Section 4. The deep trade-off between cost and efficiency. This is the core of it all, dissecting the total cost of ownership where procurement managers really earn their keep. Think of the hourly machine rate like the tip of an iceberg. Beneath the surface of an abrasive waterjet system, the crushed garnet abrasive accounts for a staggering 50 to 70% of the total operating costs. Let that sink in. If a supplier hands you a quote that seems suspiciously lower than everybody else's, you really need to ask yourself, how exactly are they cutting costs on that massive 60% slice? Well, here's the answer, and it's a major red flag for buyers. If a supplier tries to lower their quote by using cheap, low-grade garnet, it leads directly to striation, which are those rough, ugly lines on the cut edge of your parts. Sure, maybe you saved a few bucks on the initial cut, but now you have to pay for expensive secondary sanding or machining just to make the part usable. You've completely obliterated your efficiency. And there's also a hidden maintenance trade-off that can seriously mess with your delivery schedules. Pure Waterjet systems have fewer components in the cutting head. That translates to longer orifice life and incredibly high machine uptime. Abrasive systems, though, they literally erode themselves. They suffer from accelerated wear because the mixing tubes and nozzles are actively being destroyed by the very abrasive they're carrying. If you're a bulk buyer, you absolutely must factor in that abrasive projects might have slightly extended lead times just because of those frequent, necessary maintenance cycles. Finally, Section 5, Optimizing Supplier Evaluation. Let's turn all this technical data into highly actionable advice for your next request for quote. You are definitely going to want to build these exact items into your workflow to bulletproof your RFQs. First, specify the exact quality level. Waterjet speeds range from Q1, which is fast and rough, up to Q5, which is slow and super precise. If you don't specify, you're going to get apples to oranges pricing. Second, verify their garnet recycling processes. Sustainable sourcing is practically a regulatory requirement now. Third, for thick parts, request 5-axis cutting. This eliminates taper and ensures a perfectly square edge. And finally, always ask about their nozzle replacement schedule to guarantee they can actually hold your tight tolerances. Looking ahead to the 2026 outlook, the industry is moving fast. You want to align with suppliers who are actively future-proofing their shops. Look for partners who are investing in AI-driven path optimization. This predicts how the water stream will lag and allows for much faster, highly tolerant cuts. Also, keep an eye out for automatic abrasive delivery systems and advanced clog detection. These kinds of technologies drastically reduce human error and ensure super reliable delivery on your bulk orders. I want to leave you with this final provocative thought. Take a hard look at your current supply chain. Is your supplier actually optimizing for your specific material's hardness to give you the absolute best cost per part? Or are they just running whatever project they can get to fill up their machine capacity? Choosing the right process is a delicate balance of material density, cost, and efficiency. Use the insights from this explainer to reevaluate your supply chain, ask the hard questions on your next RFQ, and start sourcing smarter. Thanks for hanging out with me, and keep learning.